So, building on what Renee shared with us, what I'd like to do over the next 15 to 20 minutes is cover the basics of remanufacturing and go over things like what the process of reman looks like with some examples, specifically talk about what remanufacturing isn't, cover potential benefits, and touch on some global statistics, which I'm sure Yorian will provide greater details on. Instead of starting with the definition, I thought I'd start with an example to give you a sense of what remanufacturing looks like in practice. This diagram is from a company called Ivor Searle in the UK, which remanufactures engines. As you can see, step one on the diagram starts with the assumption that the core, which is the engine that is to be remanufactured, has already been procured, so reverse logistics isn't included in this diagram. However, it does show the systematic steps and processes involved, like disassembly, inspection, storage, ensuring that the parts meet the original specifications using processes and methods like grinding, machining, and boring. When reassembly takes place, it's worth noting that this is done in accordance with standards, either specific to remanufacturing or in accordance with original assembly guidelines, meeting all the checks, tests, and quality requirements as an originally manufactured product. In that sense, once a core has been fully disassembled, and by core again we mean the product or part that is to be remanufactured, once it's been disassembled, cleaned, and processed to a point where it's ready to be reassembled back together, from that point on, the process it follows is actually quite similar to the one that a new product would follow. So if we were to look at the remanufacturing process in a more general way, it starts with procuring the product to be remanufactured, which is reverse assembly or reverse logistics, excuse me, followed by disassembly, inspection, repairing or replacing or upgrading of parts, the reassembly process, finishing, and quality testing before it re-enters the supply chain. It's also worth noting here that the product doesn't necessarily have to go back to the original user, but could be sold back to anyone in the market. Another important point to note is that remanufactured products are sold with a warranty that is equivalent to a new product and often cost 40 to 60% less than what a new product would cost. So where does remanufacturing fit into the economy? Let's start by talking about the traditional linear economic model a little, in which there is, conceptually speaking at least, a linear flow of materials from raw material extraction to production to usage and ultimately to disposal. In reality, that's not the case in an absolute sense because many products go through multiple life cycles through reuse and repair, even if they were not intentionally designed that way. And this is really the danger of linearity, is that it doesn't account for things like multiple life cycles, ease of material recovery, ease of disassembly in a fundamental product and system design kind of way. Remanufacturing comes into play at the end of use or end of life of a product, as you can see on the far right of the linear economy diagram. And its success is contingent on not just product design, but on, like I said before, process, system, and business model design. Many of you may be familiar with the butterfly diagram of the circular economy developed by the Ellen MacArthur Foundation, which shows where remanufacturing fits into the circular economy landscape. As you can see, it's on one of the outer loops, and it's an important point to note because in some cases, repair and reuse might be preferable in extending the life of a product as opposed to remanufacturing. Putting it all together, this is the formal definition of remanufacturing based on the standard approved by the American National Standards Institute in 2017. Key points to reiterate, it's a comprehensive and rigorous industrial process. It brings products back to a like new or better than new condition, both from a quality and performance standpoint. and it follows a controlled, reproducible, and sustainable process. Now that we've talked about what remanufacturing is, we can sharpen the focus of our understanding by contrasting it against what it isn't. When talking about the circular economy, there are many words that are used, ranging from reuse, repair, recycling, refurbishing, reconditioning to remanufacturing. Part of the challenge here is that these words get jumbled together and end up getting used interchangeably, which simply isn't accurate. Just quickly talking about a couple of these. Recycling means material recovery. That's it. It doesn't take into account the form or shape or function of a product or part. It's simply about recovering something which then gets broken down, possibly to its constituent molecules or compounds, and then gets reconstituted back into a different product or part altogether. Refurbishing and reconditioning perhaps come closest to remanufacturing, but they do not carry the same rigor as remanufacturing. And what you get as a final outcome through either of these processes is very dependent on the interpretation of who's doing the refurbishing or reconditioning and what that means to them. Now, for something to be remanufacturable, certain criteria need to be met. This list is from research conducted by Boston University. It isn't an exhaustive list, but outlines some parameters that need to be considered and met at, say, the product and the market level for remanufacturing to be a self-sustaining industry. The specific technologies, methods, and market conditions will vary from industry to industry and perhaps from product to product within the same industry. What can be said is that economies of scale will play an important role, along with the efficacy of reverse logistics networks and product design. You've already heard me use the term core a few times here. This is the formal definition of a core based on the same ANSI standard. In essence, a core is a product or component that is ready to be remanufactured. It's critical to develop reverse logistics systems that can handle the core with care to ensure that maximum value can be retained. A core is absolutely not the same as scrap. At the policy level, this definition and various others in relation to waste categorizations will become important to ensure that cores don't fall under those same definitions and categorizations of waste or materials to be harvested for recycling. So what are some of the benefits of remanufacturing? According to the information compiled by the Center for Remanufacturing and Reuse in the UK, there are several. Again, these are broad categories, and the specific impact in terms of, say, job creation or reductions in raw material consumption, reductions in greenhouse gas emissions are going to be dependent on some of the same factors like product design, etc. Given where the Indian economy is, the job creation potential needs to be underscored here, as well as how remanufacturing can tie into the country's sustainability, resource conservation, and resource efficiency aspirations. Not too long ago, a report that was published by the International Resource Panel, which is a global science policy platform established by UNEP, estimated that about 79 to 99% reduction in greenhouse gas emissions can be achieved through the remanufacturing of a component compared to a newly manufactured component. The same report also said that an average reduction of 80 to 98% can be achieved in the use of raw materials when remanufacturing industrial equipment compared to producing it new. Additionally, a 2018 study by the International Labour Organization estimated that by 2030, 24 million new jobs could be created globally if the appropriate policies are established to promote a greener economy. And of those 24 million jobs, 6 million jobs could be created by transitioning to a circular economy, which includes remanufacturing. I agree that these estimations need to be taken with a grain of salt. The projections are obviously dependent on the methodology used and the assumptions made to arrive at the estimates. However, they are not insubstantial either in terms of numbers, and perhaps it's worth looking at them as aspirational. I wanted to go over one more example in relation to remanufacturing, and this is pertinent to the growing industry of electric mobility in India and around the world. Over the last few years, in India alone, several government-led initiatives have been announced to advance electric mobility, such as the National Electric Mobility Mission Plan 2020, the faster adoption and manufacturing of hybrid and electric vehicles scheme, or the FAME India scheme, and the phased manufacturing program for electric mobility put out by the Department of Heavy Industry in 2019. Electric vehicles are typically powered by lithium-ion batteries, and electric vehicle batteries, or EVBs, get replaced when their capacity reduces to 80% or below of the original capacity. When EVBs reach the end of their use phase of their life cycle, there are at least 4 options in terms of end of life or end of use options. Disposal is the least preferred, but may be necessary if the battery is damaged beyond recovery or repair, and even material recovery is impossible, say in the case of a fire. Recycling is material recovery, which is the next option. Repurposing is the third, where batteries that have been retired from being used as EVBs are used as stationary power storage units to store energy from renewable sources like solar and wind. The remanufacture of EVBs was specifically discussed at an online symposium hosted by the Trier University of Applied Sciences in Germany a couple of months back. And what was discussed was that while originally battery manufacturers did not design for remanufacturability, they are actually doing so now. What's interesting about lithium-ion batteries is that they're made up of cells, and the overall capacity of the battery is dependent on the weakest cell. So to ensure that the batteries meet the use requirements, they tend to be over-engineered. And as a result, by replacing even one cell, the weakest cell, the overall battery capacity can go back up into the range that is appropriate for use in electric vehicles, as opposed to, say, repurposing. And obviously, from a cost and resource extraction and use perspective, the implications can be quite significant. I quickly wanted to touch on the global remanufacturing industry size, just to give some context. Many of you may already be familiar with these numbers, and I'm sure Yorian will get into more details in her presentation. But the point that I wanted to make is that it's a well-established industry in various countries. And the markets are also established. It's been around for decades, depending on which specific sector you look at. And as a result, the technologies, methods, processes, engineering know-how are quite developed and advanced as well. In the US and the European Union, it accounts for close to 2% of production, and pre-COVID estimates suggested that those numbers were going to go up. Remanufacturing does occur in India, but in only a handful of industries. The main industries that we know of that are engaged in reman are the IT industry and the heavy-duty and off-road vehicle manufacturing industry. In the IT industry, the main products that are remanufactured are printer cartridges, but the sector is largely unregulated, and as a result, quality varies and counterfeiting is quite likely to be common. In the heavy-duty off-road vehicle industry, Volvo remanufactures construction equipment for the domestic market in India, and Cummins operates 2 separate remanufacturing facilities, one for the domestic market and the other for the export market. In the electronics remanufacturing industry, a company by the name of Corecentric Solutions operates a research facility in the city of Pune in Maharashtra state. The bottom line is that the full extent of legitimate remanufacturing is not clearly known in India. Part of the challenge is that the National Industrial Classification categorizes companies that remanufacture under traditional manufacturing codes. This is not unique to India as an issue. As part of our research goals, what we're interested in looking into is how to develop a clear understanding in numbers of the size and composition of the remanufacturing industry in India, perhaps through proxy indicators or other metrics. The data on this slide is a little bit old, but it gives a sense of the industries and the number of product areas in each industry in which remanufacturing occurs. As you can see, the industries range from automotive to electrical and electronic products to medical equipment and office furniture. My sense is that globally the numbers are probably higher today and probably include more industries and product categories that are listed here. So we're almost at the end of my presentation. This slide provides a high-level view of manufacturing in India, ranging from food production to pharmaceutical manufacturing to motor vehicles. What I've done is highlighted in red the industries that already undertake remanufacturing or have the greatest potential to do so. Of particular note is the mobility of our transportation industry, the electronics manufacturing industry, which recently received support to boost mobile phone manufacturing in India, as well as medical device and medical equipment manufacturing, which is categorized under other manufacturing at the bottom right-hand corner of column 3, especially given where we are with the pandemic. The last thought that I want to leave you with is that design is fundamental to the greater adoption of not just remanufacturing, but the overall transition to circularity in any economy. And we're not just talking about product design. The design of the systems, the business models, the broader environment of stakeholders matter a lot. Inculcating life cycle thinking in every aspect is critical, as well as the alignment of incentives and infrastructure, bringing greater awareness to markets and engaging stakeholders across the spectrum. So this brings me to the end of my presentation. I hope you found the information useful. Please feel free to reach out to me in case you have any questions or would like to discuss any of the material presented today. Thank you for your attention.